An overview of work done to undertake social network analysis with Spark graph frames and hollow views to render the visualization of some of the network information. And it is analyzing Wikipedia page logs, which are an XML format, taking that format, which comes in this case we're using a single dump file. This happens to be all data coming since 2004, so it's really an aggregated set of all log files. It's about 2.7 gigs. You could take the individual files. In fact, that would probably be more efficient in hindsight to take the 27 files that exist up to this point that are split out and then use the parallelism that you get from Databricks and Spark to process that. I should say I am doing this in Databricks. It's a nice, friendly environment that allowed me to focus on really the details of doing this analytic work versus all the configuration to get it running, which was nice. I'm using the Spark XML connector, which is needed to process this log data, which is an XML format. And then I'm also using graph frames, and later on we'll talk about some other libraries needed for visualization. Okay, so first off, we are going to bring in some just standard Spark SQL imports. Those are just functions and some things around structure to build the schema side of things. And we download the artifacts. In this case, like I pointed out, they're coming from, and I should say we're only going to focus on the co-edit URLs. I'm calling them co-edits. It really is just the logging URL. The one single one I realized after the fact that actually involves all data, so I only needed one. The clickstream was data that I did identify and download as potentially interesting, but just it became too much to try to incorporate the clickstream data, so I have not included that ultimately in this demonstration. We want to look at the process we go through to get the log information as it comes to us into a format that is a baseline of Parquet on which we will then remodel that further into graph-based analytics and data. So to help explain that, we have this section here in the notebook that helps us understand a couple of things. One, that there are some content edit tokens, I'll say. They're called flags here, but they're really tokens that appear in the comments section of the logging items that allows us to understand three what we call hard flags. And these are terms I've made up. Hard flag and soft flag are two terms I've made up just to help categorize this approach. And so vandalism is an obvious one, that it's been basically tagged as being some sort of vandalism. The second one is revision deletion. That has to do with inappropriate content in various forms. And criteria for speedy deletion is a broader category that yields a fast process to kick in, possibly just being out of policy, not always being inappropriate or vandalism. We're going to come back to this log to Parquet helper, which is really where the code is executed to process the initial data into Parquet. But first, let's look a little harder at the XML content itself. This is what we're starting with. There is going to be numerous log items, which each log items captures an action by a user, and that action would be the user undertaking the action would be a contributor. And so that's going to be a username that we can use and a user ID if we choose to use that as well. So that becomes important, sort of who did the action that is being logged. The other side of it is what is the target of the action, and that shows up in log title. That can be a user. It can be other things though as well. It can be against a page or against a category or a talk page. There's a whole range of them, but we really focus around pages and talk pages as kind of to keep it simplified. And then there's other information that like the comments themselves give us understanding of what happened. So all that is helpful. What we do not have is the content change itself. So we're dealing at a metadata level, not at the data level. So what we're going to do is we're going to elevate a few fields We're going to elevate the contributor information because that's ultimately going to become part of our vertices as we move forward from this stage of getting to Parquet. And then we're also going to derive some fields. So we're going to take the timestamp and we're going to get day, month, year fields out of that. Ultimately, we can use that in filtering, but we can also use that in partitioning to Parquet, which will help us be set up for longer term processing. Say we do this on a daily or weekly or monthly basis, we would have a way to add to this information. And also we're going to do a little bit of splitting on log title itself to help us understand the type of target entity, being user, page, or talk, for example. And then we're going to calculate these flags. So we have hard flags and soft flags. The hard flags are what I defined above, with the various vandalism and revision, deletion, etc. And the soft flags are flags that are more of suspected foul play, so to speak, but not guaranteed or proven, and things that deal with softer blocks that are not a firm sort of you're kicked out of Facebook for certain functions. It's more of a slap on the wrist. And then those all get rolled up into any flags. And then we're going to drop a few fields as well. Let's take a look further at log to Parquet helper, which is run as a separate notebook. So to do that, I'm going to open up inside the workspace where I have the various notebooks that were used in building this demonstration. There's 3 main notebooks, and then there's really 2 primary code-related helpers, and one's purely informational. So we're going to look at log to Parquet. And we have this definition, a function, I should say, a Python function called coerce coedits, which is really the direction that we're going, which is really toward affiliation networks where 2 users are tied to the same page as a main concept. They both have taken action on the same page and then could be seen as being affiliated. So the term coedit is sometimes used for that. So we're going to skip over the explanation. We've already gone through that. And then we're just going to look at this syntax here, which really encodes what we talked about a minute ago. We're going to use the Spark XML package to read the XML. We're going to process over a directory of gzip information. In this case, it only happens to be 1. We're going to repartition that because ultimately you get 1 partition. You need to repartition that to get your parallelism after it's read. And then we're going to go through and implement the hoisting of nested fields that we talked about, the coercion of the timestamp information to a timestamp proper, and then later we'll split out year, month, and day, do things around splitting the log title to get the type, keep the comments and do some filtering on null comments, things of that nature. And then here, this is the main section where we're actually deriving the flags that we talked about. And then from those flags, we're going to sum those up to know if we have a hard flag and or soft flag, and then the sum of those becomes the value of any flag. So that's the main content around how this is processed. This turns into a data frame and then is ready to be used further in our execution. So so essentially, now that we've gotten the data frame that we wanted, we can write that out to Parquet. And so that is a simple step. This is commented out just because it's an expensive operation, so I didn't want to accidentally run it. But essentially, we're going to write it out, partitioned by year, month, day, and very terse syntax to accomplish that. Okay, so from here, we have, and we're going to skip over clickstreams. From here, we have the opportunity to register that with the Metastore to basically be able to do SQL analytics. So we're going to create a database using Databricks Metastore, and then we're going to register the co-edits, giving it an externally path, so it'll be an external table, and we'll be able to run SQL over that, and we can verify the table, things of that nature. And then we'll move on from here to the baseline graph modeling.